Good morning to all of you. Myself, Dr. Sandeep S., Assistant Professor in Chemistry, Sri Ayyappa College, Eramallikara. Today, I am going to discuss about instrumentation of mass spectrometry. Before going to discuss about the instrumentation part, we have to know what is mass spectrometry. Mass spectrometry is a well-known analytic technique used to determine the relative masses of molecular ions and fragments by calculating the degree of deflection of charged particles in a magnetic field. The basic equation behind the principle of mass spectrometry is given that mass by charge ratio, where Z is a charge, is equal to E into B square into R square divided by 2B, where E is the charge of electron, B is the applied magnetic field strength, R is the radius of curvature of the instrument, V is the voltage applied. This picture gives a very elaborate idea about the mass spectrometer instrument. Here we are giving the sample in the form of gaseous state. Suppose our sample is in liquid state, we have to convert it to gaseous form by heating. After converting the sample to gaseous state, it is passed to the another chamber, and this chamber is known as ionization chamber. Here a tungsten filament is there, and this tungsten filament is capable to produce 17 electron volt carrying electrons. So when this tungsten coil produces the electron carrying high electron volt, it will knock out the electron from the organic compound, and the organic compound get fragment. Why? Because 17 electron volt is a huge electron volt, is capable to fragment the organic compound also. Once get fragmentation, the charged particle get traveled to the mass analyzer. In between, here negatively charged accelerating circular coil is also present. It focuses to like a collimate manner. It directed to the mass analyzer chamber. The mass analyzer is completely evacuated. So for the evacuation, here a vacuum pump is there, and when we evacuating, we can collect neutral particles and negative particles also. Here the curvature part, there is a magnetic field. Strong magnets are kept here, and with the help of this strong magnet, a magnetic field is created here. So this magnetic field affect the moving charged particles. Thereby the particle get deflected in different dimension as per their mass to charge ratio. The lighter particle get deflect more than the heavier particle. So once here a electric signal making screen is there, here when the particle get hit on the screen, it will create an electric signal. That electric signal is amplified and given to the computer, that will plot the graph. From here we will get mass spectrograph. So, and this one is known as photo multiplier. So we can conclude that the mass spectrometer consists of mainly three parts. One is ionization chamber, and the second one is mass analyzer, and the third one is ion detector. The duty of the ionization chamber is to create charged fragmented molecular ions of the respective organic compound. This mass analyzer consists of a magnet that will separate according to their mass to charge ratio when it apply a magnetic field, and that separated particles comes hit in the photomultiplier. As per their relative abundance, the electric signal get high and it can be notable. So this is a simple mass spectrograph. Here you can see that the x-axis represent mass by Z, that is mass to charge ratio. The relative abundance is plot against this mass by charge ratio. So here we can see that different fragmented having different masses. The peak with highest intensity is known as base peak, and the peak having higher mass is not usually known as molecular ion. So this is about the instruments of mass spectrophotometry. Thank you.